Hi guys, you guys are going to start your task 2.2, too big or not too big. That is the question. It's on page 9 of your module, so please, if you don't have it open yet, please open up to page 9. Today you're going to be dealing with primarily looking at the startup costs of the business Carlos and Clarita is opening. So if you'll remember, the startup costs Carlos and Clarita will have at most $1,280 to purchase cat pens and dog runs, and it costs $32 for each cat pen and $80 for each dog run. Yesterday, your group was already taking this into account and came up with a few different combination of cats and dogs. If you remember, Carlos and Clarita's father suggested that they could use 12 cats and 12 dogs, but most groups came up with that it was just too big. And most of you guys noticed that it was too big because they just didn't have the money for it. So now if we look at this, I want your group to find at least 5 more combination of cats and dogs that would be too big based on the startup cost constraints. Okay? And you're going to be plotting each of these combinations on the coordinate grid that you're going to be given. And I want you, for all the combinations that are too big, you're going to use the same color for each of those 5 points. Okay? After you find, or while you're finding 5 combinations that are too big, you're also going to find 5 combinations of cats and dogs that are not too big based on the startup cost constraint. Okay? So by not too big, I mean it doesn't use all the money. So you're going to plot each of these points on the coordinate grid, but this time you're going to use a different color than what you used for the ones that were too big. So you're going to have a second color for these points. And finally, you're going to find at least 5 more combination cats and dogs that would be just right. Okay, so just right based on that startup cost constraint. And so by just right, I mean uses all of the money, nothing left over, does not go over at all. It is perfect. They use exactly $1,280. And this is going to be plotted with a third color. So you're going to have one color for the too big, a separate color for not too big, and a third color for just right. After you've plotted all of these on the grid that's provided, grid looks like this. This is the one you're going to be receiving. It's the resource page. Should be the page 26. This one start talking about the startup cost constraints here. So I want to make sure that you have that one to plot on. Okay. Notice that dogs is on your x-axis and cats is on your y-axis. So please make sure that you're plotting according to that axis. I want to talk a little bit about what the word constraint means so that you're not confused. You got this toolkit a while ago, and I'd like you guys to look at it now, please. Oops, don't want that in there. Okay, we'll delete that. So if you'll look at this constraint, I'll pause a minute to let you guys get this paper out. Some of you might not have it. Maybe you left it at home. This got passed out with the beginning, with Mod 1 at the end. And you guys copied a number of these definitions down and filled in the examples. This was the last one that you didn't have to complete in that. So I'd like you to take that out now. So a constraint is a fact or statement that places a limit on something. In the case of Carlos and Clarita, the limit is how much money they have to spend to buy those initial crates. Okay? A constraint can be an equation or an inequality. And a solution to the constraint or to the situation must make all the constraints true. Like, they can't use more space than they have for their dogs, or they can't use more money than they have to initially buy the crates. Those are your constraints, and it has to work for all of them to be a solution. So we're going to look at this example here. So a bakery makes dozens of iced cookies and dozens of plain cookies. Each dozen of plain cookies uses 1 pound of dough and each dozen of iced cookies uses 0.7 pounds of dough. The bakery has 100 pounds of dough available. The ovens at the bakery can handle 140 dozens of cookies. Write constraints for the dough and the oven space. So when we're talking about writing a constraint, we're talking about writing an equality or an inequality. Okay? So first, let's just get down what our constraints are, just in general, just kind of what we know. So we know the bakery has 100 pounds of dough available. So that's our first one that we're going to write about. The bakery has 100 pounds of dough available. Okay, so this is our first one. And so I want to write an equation based on this. Okay, so I know I'm just gonna use x and y. I'm gonna say x is the number of dozens of plain cookies I bake, and I'm gonna say y is the number of dozens of iced cookies I bake. Okay, and so with this information, I'm gonna write an equation. I know that plain cookies take 1 pound of dough. So there's my 1 pound of dough for every dozen of cookies. And I know that my ice cookies take 0.7 pounds for my ice cookies. And all together, I can't use more than 100 pounds. Okay? So there's my equation there. Then my second constraint is that I can't bake more than 140 cookies. So the ovens at the bakery can handle 140 dozens. Oops, off the page. 140 dozens of cookies. Okay, and I'm going to use my same x and y here. Let's make some room here. And I'm going to write an equation based on this constraint. So I know altogether, all my dozens can't add up more to 140. So my plain cookies and my ice cookies, they can't be more than or equal to, I can't do the equal to sign on this, so we'll just do that, less than or equal to 140 cookies. Both of these should really be inequalities, a less than or equal to here, and a less than or equal to here, but I can't make it with the equal sign underneath on this program. So that's how I'm going to show it. Okay, so that's your constraints. Okay, I'll let you guys have a minute here before we continue on. Okay, so please make sure you have this down. If you don't have this paper, maybe just write this example on a separate sheet of paper or look on with someone else. Just going to pause. Zoom in maybe a little bit for you guys so you can really see it. Is that big enough? That's probably big enough now for you guys. Okay. Okay, we're going to go on now back to the task. Okay. So just a reminder, you're finding 5 points that are too big based on our startup cost constraint. 5 combination of cats and dogs that are not too big based on our startup cost constraint, and 5 combinations of cats and dogs that are just right, that use exactly $1,280. Okay, and I want you at this point on the task, I want you to please go through problems 1 through 5 here. If your group finishes this a little early, then you guys can go down to 6 and 7, but we're going to do this more as a class. So please make sure that your group is really focusing on this 1 through 5. If you need markers, they're in the cabinet near the door, the one with the Bambi thing on it. There's some markers in there. So yeah, all right, get started, and remember, talking with your group and only your group. The sub should not see people talking to other groups and should not see people wandering around the classroom. Thank you.